Go Math 7-9. So we are wrapping it up here for Unit 7, and we're going to be talking about the properties of math today. And this tends to confuse some people, and I really want to slow it down. Essentially, what they're going to ask us to do is solve for equivalent expressions, and they want to know, is this expression the same as that expression? Right? That's the overall goal. Can you look at these and see if they're the same? How they're going to ask us to do that is essentially with four things. The first one being the identity property. We have the distributive property. We have the commutative property. And we have the associative properties. All right, let me try and make these a little bit easier for you. The identity property, if something has its own identity, or it says it keeps its identity, it is itself. So one example of the identity property would be B plus nothing. What's your answer going to be? It's still going to be B, right? Now that doesn't work with a multiple of B. B times 0 is different. It's no longer B, it's 0. The other one for this would be B times 1. It still retains its identity. It stays the same, right? Distributive property, think of like playing cards. You're going to distribute a card to each one. So if I had 2 times M plus N, I'm distributing 2 to M, 2 times M, and 2 times N, right? And this might help because I have 2 times M plus N. Really what I'm saying is whatever this is, I have 2 of them. So I have M plus N 2 times. So when I add them together, I have 2 M's and 2 N's. So that's where your distributive property comes into play. It's a shortcut, right? Our commutative property means to communicate. So when people are communicating, they're talking back and forth. So if we had 7 times 6, that's 42. But that's also equal to 6 times 7. So to communicate, you have one person talking, and then the other person talks. It's not a one-sided conversation. So if we're moving one direction, 7 times 6, we can flip that and get 6 times 7. So the commutative property is really handy when you have something like B plus N equals N plus B. You can rearrange some of your numbers. And your associative property is sort of the same way, but if I had 7 plus 6 plus 2, I know that 6 plus 2 gives me 8, plus 7 is 15. What happens if I switch them up? And I get 2 plus 6 plus 7. Well, 6 plus 7 gives me, again, 13 plus 2 gives me 15. So I get 15 either way. Commutative and associative only work with multiplication and addition. If you're subtracting, they're going to be wrong because 4 minus 2 is way different than 2 minus 4, right? And the same thing with 4 divided by 2, which is different than 2 divided by 4. So, identity, it keeps its own self, its identity. Distributive, we are distributing this outside number to each. If I do it backwards, I look at the greatest common factor and factor it out, and that would be 2 here. Commutative is to communicate back and forth. 7 plus 6, or 7 times 6 and 6 times 7. And associative, it doesn't matter how these numbers associate with one another. 7 plus 6 plus 2, or 2 plus 6 plus 7, or 7 plus 2 plus 6, doesn't matter. They're going to give you the same answer, right? Now, let's go to our book and see what that looks like. Determine whether 10t times 4 is equivalent to 14t. So if I have 10t times 4, is that equal to 14t? And a lot of people might say, well, yeah, I've got 10t and a 4, and I'll put them together, and that's 10 plus 4 is 14. But they're asking me to multiply. And even if they weren't asking me to multiply, I can't add 10 t's with 4. They're not the same thing. But I have 10t 4 times, right? So if t is tigers, and I've got 10 tigers, in one room, and I've got 4 rooms of 10 tigers, I've got 40 tigers. And that is not equal, that's the equal sign of the line through, to 14t. So 40t is not equal to 14t, and that's how you would solve one of these. You look at the 2 things they're talking about, and you simplify them, combine like terms, move them around, make them try to be equal. And if they're not equal, you have to let us know that it's not equal. So let's look at just one more for you here, and this is 7y. 7y plus x plus, if I can write, 7y plus x plus 3y and 10y plus x. Are they equivalent? Well, I'm not distributing because it's not multiplication, but I can move them around with the commutative property. I am less interested with you knowing that it is the commutative property and more interested in you knowing that you can do this. So commutative property, I can move this around and I can essentially get x plus 7y plus 3y. Does that equal 10y plus x? Well, 7y plus 3y does equal 10y, and that would equal 10y plus x. So now we've taken the commutative property and we can explain it using the associative property. Those are really just big words that mean you can move these numbers around, and they have rules on how you can move these numbers. So again, I'm looking for, are these equivalent, and what ways can I manipulate the numbers to make it work?